Okay, well, it's 7:05, so we're going to get started here. Thank you all for joining the 7th Annual Wallkill River Watershed Alliance Summit. This is part 2 of this year's summit. We want to say thank you to the Hudson River Watershed Alliance. They have been supporting us with Zoom throughout the last year, and this wouldn't be possible without them. So thank you to Emily Vale and all the people at Hudson River Watershed Alliance for supporting us with this. And without further ado, I'd like to introduce Rob Ferri, our treasurer, who will be presenting on his MS4 training program, as well as Brian Duffy, Alene and Lauren Townley from New York State DEC, and they'll be presenting on their water quality monitoring. So Rob, I'll pass it over to you.
Okay. Thank you. Let's see, here we go. Hi, this is assisting municipalities with municipal separate storm sewer system, MS4, permit compliance, or stormwater fun with your friends. I don't mean raccoon friends, I mean your environmental friends. Some of us have friends that like to travel with us or go to the movies with us. Some go out to eat with us, and some like to do environmental projects with us. And that's sort of what this talk is about, doing environmental projects. My name is Rob Ferri. I'm a retired US EPA water enforcement, and I'm also retired Navy. I guess I'm a water nut, really. The municipal separate storm sewer system. The title is quite a mouthful. As you might imagine, there's 3 different types of, there's a little definition here of what an MS4 is, but the separate storm sewer system, oh, I spelled sewer wrong. Anyway, there's 3 main types of sewer systems. There's sanitary systems, there's separate systems, there's storm systems, they're separate, and then there's combined. The combined is the sanitary with the storm. They're the problem guys, the bad guys, but we can't really talk too much about that right now. That's not really in our purview of this talk, but the storm system, which typically runs to outfalls that goes to our streams, that is something we can talk about. It's something that's around all of us. It's something we all see. There's a couple of pictures here of a labeled drain that's properly labeled, lets you know where the water is going. The picture on of the outfall, that's a construction site. The construction site was just discharging that one day, and there was enough sediment going into the water to completely brown out the water. The MS4 program basically is about managing the pipes and the swales, the conveyances in your municipality. It allows not just managing your pipes, but how your pipes connect to other people's pipes, your neighboring property pipes, and the idea is to keep pollution out of these conveyances, your pipes and your swales. And the way it's done is with the permit, an MS4 permit. The MS4 permit has, like any good permit, it has 6 different measures. These are the things that when the state or the federal government come in to check, they ask about. There's public education and outreach and public participation and involvement. that's sort of what this talk is going to be about, because, well, it's a talk to the public for one thing, and it's something that it's all around us. We all see these things. We all see storm drains. We all see the rivers. We see if they're clean or not clean. The other measures are things that really, it's more regulatory, it's more paid staff type of thing. It's illicit discharge detection and elimination. That's more like finding it and fixing it for the town. There's construction site runoff control. That's more like checking to planning where the cement pits are, where the soil piles are, making sure that there's gravel at the beginning of the construction site, things like that. There's also post-construction runoff control. That's more along the lines of retention basins and making sure that they don't fill up with sediment and then overflow and really basically do nothing. And then there's pollution prevention and good housekeeping. That's more along the lines of the town actually taking care of their DPW, their facilities, keeping good documentation. It talks a little bit more about road salt. That's always a big topic with pollution prevention. So, assisting municipalities. That's really what this talk is about. Since listeners are the public, this talk is about those first two parts: public education and outreach, and public involvement and participation. Most MS4 permitted municipalities don't have enough time or staff to spend educating and organizing the public on stormwater. It's one of their low-hanging fruits. I mean, they're going to do all of the good housekeeping. They're going to keep their public works department in good shape. They're going to try and keep their roads in good shape. They're going to be checking where there's leaks in the pipes and fixing those leaks in pipes. They're going to be, they have staff that they pay to check construction sites, but most of the municipalities don't have people out organizing the public. They need non-technical help. They need help by people like us just attending the environmental events that happen. As an individual, you can just show up and attend different events. And well, this is my favorite slide. Or you could be an active and involved community or be part of one. And if you're part of an environmental organization, well, you can partner with a municipality, because after an event, any event that happens, these environmental events happen, if your environmental organization puts one on, and I see environmental organizations all through the spring, the summer, and the fall. There's dozens upon dozens of them all through the towns in the Hudson Valley, actually the whole state. And one of the biggest shortfalls is after the event, there's no partnering with the municipality. There's no report sent to the stormwater manager of the town. And the report, well, it's not really a lot. It's a brief description of the event, some metrics, in other words, how many people attended, how many flyers were handed out, how many people were recreating on the river during your event, some social indicators, how the event went, were attendees enthusiastic, what could be improved, anybody asking any questions, did attendees learn anything, all kinds of things that are fairly easy to write up if you were there. And a few pictures of the event. I tend to write these reports up, and they're usually about 80% pictures and maybe 10 or 20% of actual, writing sentences for these things. But for the most part, it's a good idea to do this as an environmental organization. It really helps the municipalities. It keeps them in compliance. It keeps them from being fined. When towns get fined, when small towns get fined, they wind up, either thinking about raising taxes or reducing services. It becomes a real problem. And it's not a big push on an environmental group to do these little reports, because besides doing these reports, you get a little history of your organization. So what are the things you can do? What kind of events are we talking about? Well, there's public education and outreach. That's the first measure that the towns need to do. And most towns, it would cost a great deal of money for them to do these things. To hold a summit on science-based steps that can be taken to improve water quality. This is one of the summits. Hold an environmental fair to educate the public on water quality issues. Initiate a river race or an environmental fair to educate the public on recreational opportunities, access, and water quality issues. You can hold municipal separate storm sewer system classes to train municipal staff, or at least that's what our group has. Not everybody has a trainer to do that. We've offered a kayak self-rescue class, because if we're going to ask people to go out on the water, well, they should be safe. And we've held roundtables for the government and NGO leaders on improving the water quality of the Wallkill River. We've participated with Ulster County, had roundtables. The Hudson River Watershed Alliance is also going to have a roundtable fairly soon. And we encourage you to attend these. And now now we've done all the wordy part of the talk, and it's going to be a lot of pictures from now on. Our summit was in 2018. We had a summit, nice little list of speakers. We've had a Wallkill River Festival. We had entertainment, and it winds up that it tends to be a lot of fun for the entire community, and you enjoy yourself too. Oh, here's Frank Benedetto, New York State DEC Fisheries Unit, showing us one of the fishes he caught during the fair. And also there's reporting toxic algae blooms. If you see something that looks suspicious, we've called in the state and they've come out and sampled very quickly, amazingly quickly. We've also had, well, these are some of the pictures of the events that I talked about. There was the Wallkill Summit in 2019. We had a training on how, from the state actually came out and taught us how to check catch basins in particular. And then the other photo of the kayakers, those are the guys that were on the self-rescue event. Here's some pictures of roundtables, roundtable events, the Wallkill River Roundtable, the Ulster County Roundtable. We held an environmental race and fair. That was really well received. It was surprising. We have a couple of our racers here with their numbers. It was a good time for all the racers. It was a good day too. And we set up a little tent and table for people to come by and ask questions and talk about the river. And the other part is public involvement and participation. To actually get people involved, not just educating them, not just outreach to them, but let's have some fun. And what we're talking about is we participated in the New Paltz Regatta to educate and bring attention to the public on water quality, floatables, wetlands. We participated in Wallkill River tree planting with the Trees for Tribs program. We've been involved in river monitoring, public paddles, cleanup events. The cleanup events they usually wind up being more fun than you might think. There's tire pulls on the Wallkill River. We've led or assisted in land and water quality cleanup events, and we also adopted a portion of state roadway to also clean up the area and keep the debris and the floatables out of the river. Here's a picture of our water bottle boat. It's to It's designed to show, to fight single-use water bottles. And there's our staff there, or at least part of our staff. We also had a boat that we made with a wood duck. There used to be a lot of wood ducks on the Wallkill River, and they're really not around as much anymore. I mean, not that there's a shortage of them, but they're not visiting our neck of the woods anymore. And then there's tree planting. There's some tree planting pictures. We planted plenty of trees along the river. We're still planting, I guess, some trees. 2019 and 2020. And then there's river monitors. We actually monitor the river on a regular basis. If people want to put in some data about river monitoring, if they go for a kayak ride, all you have to do is go into a website that we have. It's called wallkillalliance.org, or just one word, wallkillalliance.org. And if you go in there and click on a picture of these two young gentlemen here, you'll go right into a monitoring report, and you can put in some information about the river. We've had some public paddles. The evening paddles have been the most popular. To do a little sunset paddle, we've been in touch with from Sojourner Truth Park. There's a guy, Craig, there that has a kayak rental place that's helped us out, get a big crowds of people actually out on the river at night. It looks really nice. It's a nice thing. And tire pulls. I think our group is tire pull crazy, but we've been pulling a lot of tires out of the river, more than you might imagine. And there's still plenty to go too. So, but the municipalities nearby have been very cooperative, very helpful. They've been taking the tires off us. It's really been a good program so far. We've been trying to clean up the Wallkill. We've been participating with Riverkeeper and the Riverkeeper sweeps. We've assisted Riverkeeper staff, and we've actually been the leads at some sites in cleaning up the river. There's 2019. It wasn't, we didn't really clean up much. In 2020, it was sort of an informal cleanup. And then in 21, we got back to the old real cleanup setup. And yeah, as you can see, people kind of get competitive about picking up as much as they possibly can. But it's usually a good time for everyone. And then here's our highway crew. Yes, it looks like a day-glow colored banditos here, but we have a little section of the road, and every year we go out there and we clean it up, and you know, just makes things much better for everyone. And we're back to my old favorite slide again. This is the gold star slide. This is, if you're an individual and you're not in an environmental organization, just go to an environmental event. That's helping. That's really helpful. And if you're part of an environmental organization, see if you can partner with an MS4 municipality, because they need reports of events. And I'm sure your environmental organization has events. There's so many events all year long. And all you have to do is, like I said before, write a short report and send it to the stormwater manager. And that's a brief description of the event, some metrics of attendees, flyers handed out, some social indicators, how the event went, were attendees enthusiastic, who could be, what could be improved, any questions from people, any important questions that maybe should be brought up to a higher level. Did attendees learn anything? And a lot of nice fun pictures of the event, because fun pictures is really where it's at. And here's some extra credit. If you work for a municipality, or if you're involved in stormwater issues, the Department of Public Works, a town garage, you're a planning board member, a municipal engineer, etc. This is MS4 training. This is what you're supposed to know about. And so if you want, you can email me your name and the email of your stormwater manager, and I'll send them a little note saying that you attended this training. And, my email's right down there, rferri123@gmail.com. You attended a little training. And well, I guess that's it, unless you have any questions for me.
Rob, thanks so much for your presentation. This is Emily Vale from the Hudson River Watershed Alliance, and I'm helping out the Wallkill River Watershed Alliance with moderating some Q&A tonight. Just think it's really impressive, all the work that the Wallkill River Watershed Alliance has been doing and shown in those photos, but also connecting the public with the benefits for municipalities of participating and getting that credit through the MS4 program. So we do have a question that came in here. Lots of great work, congrats and thanks. The question is, do events have to include education about stormwater pollution to qualify as MS4 education? Otherwise, it seems like claiming credit for something that doesn't contribute to stopping water pollution via stormwater.
Well, you have to have a tie into stormwater. It does have to have that, but it doesn't have to have stormwater education. It could be, like participation if you're just putting more access to the river, getting more attention to the water quality of the river. Maybe you're not educating people, but you should be getting more people out on the river, more access to the river, more participation. You need some link to the stormwater cycle, if that's helpful.
Yep, great, thanks, Rob. And I'm not seeing any other questions, so I think with that, we'll hand it over to the DEC team for the next talk, but we'll have more time for Q&A, so if you have other questions for Rob, be sure to put them into the Q&A box at the bottom of your screen.
All right, is that showing up for everybody, Emily?
Yep, looks good. And if you want to turn your camera on too, Brian, if you have the bandwidth.
Okay, we'll see. All right. Okay, well, thank you guys. Thanks, Rob. That was interesting for sure. I wasn't expecting a presentation before mine. That was good to see. And it also made me realize I needed another picture or two in mine. So I added a few bug pictures to this upcoming talk. So I'm Brian Duffy with the Stream Monitoring and Assessment section. And, I think I just wanted to preface our presentation by saying that when Emily and Kyle asked us to come in here and present, the real intent of this is to provide a true update to the sampling and that we reported on and presented 2 years ago that really was representing the 2017 and 2018. So we're adding data to essentially what we presented previously. So part of that means talking about data we collected from Sturgeon Pool. So we have also Alene Onion from the Lake Monitoring and Assessment section to talk about that. And then following her is going to be Lauren Townley from the Bureau of Water Resource Management to provide an update on the TMDL and sort of talk through what that process is going to look like. So a basic outline of what we're going to talk about today. I'm going to talk about the background for this sampling, and a lot of which everybody is going to be intimately familiar with, the objectives of the monitoring that we conducted, and then some of the details on the monitoring that we conducted, including the methods and results. I'm going to be talking about the watershed, and by the watershed, I mean the streams and rivers throughout the Wallkill watershed, and then Alene is going to talk about Sturgeon Pool and information that they generated between 2019 and 20. And then, as I mentioned, Lauren's going to talk about the TMDL and direction where we're headed with the watershed. So the background, right? Again, not anything that you're probably unfamiliar with. There's water quality issues throughout the basins from a variety of pollutant sources. And the real focusing event, I think, really was going back to 2016 with the algal blooms that span 30 miles of river from Sturgeon Pool to Montgomery. That really highlighted a lot of what needed to be done throughout the basin. We know nutrients are an issue, or tend to be an issue throughout the basin. Low dissolved oxygen is another one of the pollutants and issues we deal with in the watershed. And then altered hydrology is another important one. There's several dams along the main stem Wallkill that change the way water flows through the system, and certainly, as Alene will speak to, can alter or stream flow and potentially increase the likelihood of algal blooms, as we saw. The watershed itself is a mix of agricultural land use. So we have phosphorus and other nutrients coming off the agricultural landscape, particularly from the upper watershed. We have urban stormwater, I think Rob was speaking to previously, largely starting with that urban land use around the middle of the watershed near Middletown. And then again, as a result of the urbanization, we have a lot of wastewater treatment facilities. So the Wallkill has a variety of pollutant sources in kind of a mixed bag. And as of 2017, when we started monitoring, only Quaker Creek and Monhegan Brook were on what we call the impaired waters list, or 303D list, those waters that have been identified as needing some sort of restoration measure to restore water quality. And most other tribs were unassessed. And we needed to collect the data to then act on it from DEC's perspective. And so that was what really started the monitoring effort and why we needed to collect the data that we did. The objectives then, and they continue to be, were to cover a range of watershed size and conditions. So while we had waters on the 303D list, that we were not looking to only collect data on water bodies that were known to be impacted or assumed to be impacted by degraded water quality. We wanted to collect data on water bodies of all conditions. And that included monitoring the tributaries throughout the watershed, along with the main stem of the Wallkill itself. Another important part of one of the objectives were to focus on stream flow throughout the watershed. And we had an existing USGS stream gauge at Gardner at about river mile 19. So just a little bit about river miles. We tend to think, at least in the stream program, about our sampling locations in terms of river miles from the mouth. So you'll see that throughout the presentation a bit. And in the case of river mile 19, we're talking about 19 miles upstream from where the Wallkill flows into the roundout. You'll see that again several times. We had an existing stream flow gauge at Gardner, and we installed another two. One was at Phillipsburg at river mile 44, and a third up at Unionville, right at the New York-New Jersey border, about river mile 60. And the stream flow gauges really provide important context for the water chemistry data that we're collecting and how that interacts with stream flow to calculate loadings. And that's going to become important for what Lauren's talking about in development of a watershed model. One thing that we were missing originally was Sturgeon Pool information, and that's what Alene, as I said, is going to speak to. So that initial data set we discussed 2 years ago in 2019 covered the 17 and 18 monitoring. So we had established sites all the way from river mile 2.0, just above Sturgeon Pool, to the New York-New Jersey border, right at river mile 60. This is where that Unionville stream gauge is. And as I mentioned, the gauges provide important chemistry context, and they really divide up the basin into three segments. We had a gauge at the border here, right around Middletown here, and then another at right down here. So it serves to parse up and should be helpful in terms of developing that watershed model. And another thing I like to note is that the tributary information that we collected included samples from both DEC and collected through the Peers program, and the Watershed Alliance and the Riverkeeper certainly helped us to expand our capacity within the watershed. And we talked about that last time. The parameters that we were looking at then, and that we also have collected through 2019 across the watershed, included, as I mentioned, water chemistry. And we were really looking to capture a range of stream flow conditions. So low flow and high flow. So low flow when you haven't had a lot of rain in a while and the stream levels are low, but then also trying to look at what the concentrations of parameters like phosphorus were at high flow and how in what those are going to look like and as they relate to the stream flow information that we're collecting. We also collected information on temperature, dissolved oxygen, pH, conductivity when we were out sampling, and then lab analytical chemistry on things like base cations and anions, alkalinity, chloride, magnesium, and then of course nutrients, which is a big focus: ammonia, nitrate, total phosphorus, total nitrogen, things like that, metals, turbidity, chlorophyll A, and then instantaneous discharge. Along with the stream flow that was generated at the gauges, we're also collecting instantaneous discharge where we could alongside of our water chemistry samples that we collected in order to get instantaneous loads that hopefully will be helpful in the future modeling efforts. And then macroinvertebrate community information. So how do all these water chemistry parameters manifest themselves in terms of the aquatic insect community or macroinvertebrate community? For this project, and like all projects that we undertake, we always strive to collect representative samples. So representative samples, representative spatially in terms of the watershed, which we did, as I mentioned, but also representative samples of that sampling location. So by that, I mean depth integrated eco-WIS sampling. So we are collecting water chemistry across the stream, right, across the transect of the stream at several sampling points, and they are depth integrated as well. We composite all of these samples across the transect, across that cross section, and get a representative idea of what's going on in terms of the water chemistry parameters. The same thing for instantaneous discharge, for breaking up that stream into the same type of segmentation and calculating stream flow at each depth, adding that together to get our instantaneous discharge, to get instantaneous loads of each of our parameters, including phosphorus. So then 19 and 20, right? So this is what we did that was new and that we didn't talk about in 2019 at the last Wallkill Summit that I attended. The objectives of the more recent monitoring were to support watershed planning efforts and updated assessments by collecting and ensuring that we had at least 2 years of monitoring data at sites throughout the watershed. In 2019, we collected 10 sites that we were collecting water chemistry data at. That included a handful of main stem sampling locations, one at New Paltz, and then we're continuing to monitor the gauges sort of to keep our fingers on the pulse of the watershed. So Gardner, Phillipsburg, Unionville were also included, and then we had several tributaries that we were looking to collect a second year data on, and that included the Swarterkill, Plattekill, Dwarkill, Rutgers Creek, Tinbrook, and Pochuk. And then Sturgeon Pool played a huge part of the 19 and 20 effort that Alene will speak to again, as I mentioned several times. So up until now, I've kind of talked about it as then and now. And now I'm going to put it all together, right? And the data that I present in the next handful of slides is going to be an aggregation of the 2017 to 2019 data. So a little about these figures. This is a map of all of our sampling locations. The next one is going to be a figure on total phosphorus concentrations. And then following that, I'm going to talk about how the macroinvertebrate community or the aquatic insects responded to phosphorus throughout the watershed. So a little bit about the way they're displayed. We have main stem Wallkill sites are shown in purple, right? You see the triangles throughout here. That color scheme is going to carry through to the following figures. Because the main stem of the Wallkill is divided up into 3 segments, the tributaries to those segments are color coded as well. So upper Wallkill tributaries are shown in blue, as you see here. Tributaries to the middle segment of the Wallkill are green, and then to the lower segment, they are orange. So that color scheme is going to carry through in the following 2 figures. So here's total phosphorus in milligrams per liter. It's on a log scale, so it's a little bit different of a scale in case you're not used to this. But up here at the top, we have 3 milligrams per liter of phosphorus, and we have 0.03 down here. And as I mentioned, color coded. Wallkill main stem sites are in pink. Blue are the upper, green are the middle, and orange are the lower. And from upstream to downstream, left to right. So here is our river mile 60.1, that site at Unionville at the New York-New Jersey border. And then here are several of our main stem sampling locations. This is right around Middletown. And here is our site just above Sturgeon Pool. So a couple of things I want to point out, right? One, you probably noticed are these sampling locations where you have extremely high concentrations relative to the rest of the watershed. One of those sites was Quaker Creek, right? That was one that we mentioned earlier that was already on 303 list for impairments to water quality. Another was the Rio Grande, and another was the Chi-Chunk. So when you have concentrations upwards of 3 milligrams per liter, typically that's a result of high influence from a wastewater treatment facility. So you have a low flow, small stream that has a relatively large effluent discharging to it, and the concentrations that we saw for phosphorus really reflect that. So that definitely jumps out as a something that probably drew your eye here. The other piece I wanted to mention was kind of this crescent shape that we see for the Wallkill main stem phosphorus concentrations peaking right around Middletown, where you have that transition from agricultural dominated land use in the upper watershed and transitioning to the more urban dominated landscape going downstream. And we certainly see a high point here through the figure, dropping off as you move downstream slightly, and the tributaries kind of reflect that same downward trend. So, that provides the context throughout the watershed, what's higher and what's lower, but to really provide context for how high these concentrations are in the absence of a water quality standard for phosphorus, which we don't have, or in any other water quality parameter that we don't have standards for, we typically present percentiles. And so if anyone remembers from 2019, we talked about percentiles of the entire lower Hudson Basin that for phosphorus concentrations that we've collected over the last 20 years to provide that context for how high the concentrations in the Wallkill are. So the 25th percentile of all the phosphorus data that we've collected for the last 20 years in the lower Hudson is 0.02 milligrams. So meaning 25% of our data has been under this line in the lower Hudson. So only 2 data points in the Wallkill for the 3 years that we monitored in the watershed were below that line. The 50th percentile is 0.04 milligrams per liter in the lower Hudson. So 50% of the data we collected was below 0.04 milligrams. And then the 95th percentile of phosphorus in the lower Hudson watershed for the last 20 years has been below a value of 0.19 milligrams per liter. So it really puts, I think, in context the concentrations of phosphorus and how high they are relative to the rest of the watershed. So then the next thing I'm going to talk about is how these concentrations in water quality affect the aquatic life in the river, right? So the macroinvertebrate community, the aquatic insects, as I mentioned. We employ 2 main sampling methods for collecting macroinvertebrates. The first is the kick sampling method. This is kind of our bread and butter of the way we collect bugs across the state. It's a methodology we use for wadable streams with hard bottom substrate. So it involves kicking loose the rocks and cobble and collecting the organisms and detritus that are swept downstream into our net. We do that over a 5-meter period. And then the other main sampling method we employed was multi-plate method. And this one's actually been around for almost 50 years in our program. And it basically involves an artificial substrate, these multi-plates that are deployed for a period of 5 weeks at 1 meter below the surface, during which time the invertebrate community colonizes them. And then we come back at that end of that 5-week period, pick them up, and then for both methods, count what we've collected essentially. And these are those pictures that I added at the last minute there after Rob's presentation, just to show some cool images of macroinvertebrates, aquatic insects, and the kind of things that we typically collect in these type of sampling methodologies. So we need a way of going from that invertebrate community to a number that we can use from a management perspective and tells us how good or bad water quality is. So in New York, we calculate what we call a biological assessment profile score, and that's a multi-metric index of water quality made up of component metrics that tell us about the structure and function of the aquatic insect community. What the BAP score tells us basically is as levels of stressors such as phosphorus, for instance, increase, we're going to see a decrease in the BAP score. So that's an important thing to note. For this next figure, we're actually looking for high BAP scores rather than low flow values, as we opposite of what we were looking at for phosphorus in the previous figure. So as stressors increase, BAP score tends to decrease. The BAP score falls on a 10 scale. We divide that 10 scale into 4 impact categories. BAP scores of greater than 7.5 are non-impacted. Slightly impacted BAP scores are those 5 to 7.5. Moderately impacted BAP scores are 2.5 to 5, and severe impacts are those that are less than 2.5. We draw our proverbial red line at a BAP score of 5, and the values below that tend to indicate a potential water quality impairment. So something like phosphorus, for instance, will cause BAP scores to drop down below this score. So here's the BAP scores that we generated throughout the waters. There's a few less BAP scores in sampling locations that we had BAP scores at because of limitations due to habitat. Sometimes our methodologies aren't applicable. So you'll notice a few fewer sampling locations on this figure, but the layout is the same. Again, we have the upper watershed here. This is the Unionville site at the New York, New Jersey border, and our Wallkill 2.1 just above Sturgeon Pool here. And then moving, of course, as I mentioned, upstream to downstream. These sampling points are the average of several replicates that we collected. In a study like this, we tend to collect more than one sample at each location. So the dots are the average. The bars that you see represent are what we call the 95% confidence intervals, meaning we're 95% certain that the average falls between the top and the bottom of the bars, right? So where we have, and in this case, we have wider confidence intervals, meaning the BAP scores were a little bit more variable. Where we have narrow confidence intervals, the BAP scores tended to be very similar to each other. So again, a couple things to note, right? So here is Quaker Creek, right? That was one of our high phosphorus sites that jumped out in the upper watershed. Phosphorus concentrations upwards of 1 to 2 milligrams per liter. Here's the Chee-Chunk, right? Another one that had concentrations close to 3 milligrams per liter. So, certainly we're seeing a reflection of those phosphorus concentrations in the BAP scores here. And then the middle Wallkill, right, hovering right around 5, and a handful of other sites dipping below BAP scores of 5 for sure. But the main takeaway, and the thing I like to point out on this figure is that this is very much a eutrophication signature in the watershed, according to the BAP score. We tend to see this kind of sort of low-level degradation at a lot of sites, and then at some sites that we have more extreme degradation to water quality from phosphorus, we tend to see BAP scores dropping below 5. But having it kind of confined to this narrow range of 2.5 to 7.5 typically is an indication of eutrophication throughout the watershed, and certainly a signature of that we're seeing in the Wallkill. So with that, I'm gonna pass it on to Alene to take over for here.
There, thank you, Brian. Okay, so I was asked to speak about HAVs since 2016, since the harmful algal blooms are managed by my section, the lake section, lake monitoring and assessment section. So here's a summary of the reports we received since 2016 when the river turned green, as Brian said earlier. My colleague, Rebecca Gorney, manages this program and tells me that most of the blooms occurred in September and October, and particularly at the impoundments or dammed sections of the river. The lower Wallkill has several dams at Montgomery, 2 at Walden, in Wallkill, at Riften, including Sturgeon Pool. These impoundments slow the water retention time and presumably allow temperatures to climb, both of which improve conditions for the cyanobacteria that cause the harmful algal blooms. Now, keep in mind, this monitoring is by no means comprehensive. We rely on volunteers like you to report on the blooms. And there are ephemeral events that could present in the morning and be gone by the afternoon. So we strongly suspect that there were more blooms that occurred than are reported here. The key message is we need your help. And Rob said this earlier in his talk. If you see it, report it using our online form, and I've given you the link to that form there. And to be clear, it can be really difficult to identify a bloom, so please report any suspicious surface accumulation. For example, here are 2 photos, one that is and one that is not a harmful algal bloom. I'm just going to pause for a second to let you guess in your mind which one is the harmful algal bloom, and then I'll tell you. So the one on the left is the harmful algal bloom. The one on the right is a bloom of Euglena. It was confusing even to our professional staff. In fact, Rebecca Gorney came down and met Jen Epstein at this location to study this Euglena bloom because it was so confusing. But again, the main point is if you see it, report it, because that data helps us track the harmful algal blooms across the state. Brian, would you go to the next slide, please? Thank you. But moving on to the main reason why I'm included in this presentation today is Sturgeon Pool. Sturgeon Pool is a Class B ponded water in Riften, New York, and it's the only section of the Wallkill River that is classified as ponded. As a Class B ponded water, its official designated use is for both recreation and fishing, depicted in the two photos you see here. It's important to note that recreation includes primary recreation, such as swimming, as well as secondary recreation, such as boating or wading. The purpose of our monitoring was to determine whether water quality in Sturgeon Pool is sufficient to support these uses, recreation and fishing. So Brian, go to the next slide, please. Thank you. So first off, is the water quality in Sturgeon Pool suitable for recreational uses? As Brian showed us, the Wallkill system has high nutrient levels. High nutrients cause algae blooms, which are unpleasant for recreation, as you can see in these photos on the right. So the fact that algae blooms are unpleasant for recreation, we actually documented in a 1993 statewide survey. We asked citizens of New York at what point the water quality is so bad that it impedes recreation. The result is a nutrient threshold. Specifically, recreation is considered impacted when phosphorus concentrations are above 20 micrograms per liter. So back to Sturgeon Pool. We sampled the pool 7 times over the course of 2019 and 2020. Unfortunately, all of these measurements were above this threshold of 20 micrograms per liter phosphorus. In fact, all of the measurements were actually 4 to 20 times this threshold, so they were very high. Therefore, we concluded that recreation in Sturgeon Pool is impacted by these high phosphorus concentrations. So Brian, next slide, please. So that was recreation. Now fishing. Is the water quality in Sturgeon Pool sufficient to support fishing? Unfortunately, oxygen levels are very low in Sturgeon Pool, 37 to 75% of the water column. So imagine taking a cross section of the water column from the surface all the way to the bottom. That means that 37 to 75% of that distance from top to bottom had oxygen levels below 4 milligrams per liter, which is the threshold for fishing use. Now, keep in mind, this is a consequence of nutrient enrichment, so it's all related. Since nutrients increase respiration, which consumes oxygen, if you remember from your intro bio course. The highest oxygen levels were observed at the surface of Sturgeon Pool because wave action and photosynthesis actually generate oxygen in the system. Unfortunately, most fish species cannot live at the surface because the temperatures are so high. Therefore, the fish are squeezed on both sides with high temperatures at the surface and low oxygen coming from below, leaving only a very narrow window in which they're able to inhabit. And this window is, as I said, particularly narrow in Sturgeon Pool since so much of the water column has uninhabitable oxygen conditions. So therefore, we concluded that fishing in Sturgeon Pool is impacted by low oxygen levels caused by high nutrient concentrations, likely caused by high nutrient concentrations. So next slide, please, Brian. So conclusions. In conclusion, there are elevated nutrient concentrations across the Wallkill River system, which are demonstrably impacting the macroinvertebrates community, as Brian showed us earlier, as well as the designated recreational and fishing uses of Sturgeon Pool. We are continuing baseline monitoring to keep our finger on the pulse of the Wallkill, as Brian says. We're maintaining the gauge sites and doing this baseline monitoring. So with that, I would like to turn it over to Lauren.
Great, thanks, Elena. Let's move this over. So now that we've gone through all this monitoring information that Brian and Elena have presented, we've compiled all that information, been able to use it to update the assessments for the main stem, as well as the tributaries to the main stem of the Wallkill. Now have enough information to update the assessment of Sturgeon Pool. So we're moving into the planning and management stage of what we're going to be doing about the impairment that exists in the Wallkill and what restoration actions are going to come next. So you can go to the next slide, Brian. You can just go through all the bullets together. So what DEC has decided is that we're initiating the development of a total maximum daily load, or a TMDL, for phosphorus specifically. So a TMDL is a type of clean water plan that DEC is required to develop for impaired water bodies that are not meeting their best use. And what that plan entails is all these things that are shown in this slide. So we characterize the watershed and the water body itself. We use water quality models to define the pollutant sources, as well as how much pollution is in the system itself. We define the reductions that are needed to meet the water quality targets and assign those reductions amongst the pollutant sources that we've identified. A component that's really important to a TMDL is the implementation plan section, where we list the management actions that are going to be taken to meet that reduction requirement. And as part of the development of the TMDL, there's a public participation component. So we will have public meetings and a public comment period as well, where we will get feedback from all the stakeholders that will be impacted by the development of this plan. And once the plan has been developed, it sets up the watershed to receive priority funding through our state funding programs for implementation of projects that would reduce phosphorus. So you can go to the next slide, Brian. So there's, so you can keep going down the different bullets. There's many components or data sources that go into the development of the TMDL model. So this is just a list of them. So we identify the land uses. We pull in all that water quality data that Brian and Elena have presented. We look at different inputs from septic systems, as well as our wastewater treatment plants that are in the watershed. Pull in weather data because the nutrients are highly dependent on flow and runoff from different weather events. We characterize the topography, geology, soils all play into how nutrients are moving through the system, as well as the water body characteristics. So Elena and Brian both mentioned that there's different impoundments throughout this system that we will try to model as well. And we do outreach to partners that have been involved in implementation. We like to include existing implementation efforts into the model itself. So that helps with the baseline. So incorporating any type of MS4 activities or green infrastructure, farming practices that have already been implemented can go into our baseline model. And at this point, we have a lot of this information available to us already that we can pull into the model. The next steps are identifying the types of models that we'll be using to develop this TMDL plan, and then going through that modeling process. Once the model is developed, we will draft that up into a plan and then release it to the public. So at this point, this is where we're at in the stage. And I think, Brian, you can go to the next slide. I think that was my last slide. So we can take questions, and we have just Brian's information, I just realized, up on the slide. But if there are other questions, we can take them now. But if people have questions later on, they can email Brian and he can get them to Elena or myself.
Sorry about that, Lauren and Elena. I missed that piece.
Well, it's okay. I just noticed that.
I did too, as I was getting ready to change to the last slide.
I think you just volunteered to be our communications director.
Yeah. Right.
Great. Well, thank you so much for your presentation. We have a lot of questions coming in, unsurprisingly. So let's jump right in. In describing the very high phosphorus and low dissolved oxygen in sturgeon pool, Elena, you used the word impacted, not impaired. Can you explain the significance of that distinction?
I saw that question from Dan Shapley, and you're very astute. I was deliberate in my language because there hasn't been a published assessment of the water body, which is why I use the word impacted and not impaired.
Is a published assessment to come at some point, or is that like a part of the process?
Yeah, so as many on this call know, we each serve our respective roles at DEC. So Brian and I are in charge of monitoring, and then our colleagues in the assessment section actually compile this information into the official assessment that goes to EPA. And yes, that is in process.
Okay, great, thank you. What is the estimated timeline for the TMDL? And then I'm going to combine a couple questions here. So what is the estimated timeline for the TMDL? What are some next steps? And how will the success of implementation be measured?
I'll take maybe one at a time. So I heard, what's the timeline for the TMDL? So at this point, it's hard for us to estimate. We are in the beginning the modeling stages. That can take some time depending on the outcome of that model. Then we have to draft it, put it out to public notice, EPA reviews it. So it's likely several years down the road before we would have a final TMDL. So that's sort of the time frame that we're working with. It's not a really quick process, but we are, getting the ball rolling on that process now.
Great. And once the TMDL is completed, how is implementation of that plan measured?
Yeah, that's a really great question. So we will, provide funding for implementation. So we'll track projects that are implemented through that mechanism, and then we'll continue doing the ambient water quality so that eventually we will see or hope to see the improvement in the actual ambient water quality, though that takes quite a number of years to potentially see those changes. But between the tracking of the actual implementation projects going in, we can use some modeled estimates in the meantime to determine how much reduction we're gaining from the implementation. And then, as I mentioned, continuing that ambient water quality monitoring over time to see that impact.
Great, thank you. In yesterday's talk, there was some talk about arsenic, and someone's commenting that they see arsenic in the list of measurements, and that last night it was discussed in relation to fish and fish health. What do the data show in New York about Wallkill, acknowledging that there are some problems with the section of the Wallkill in New Jersey with arsenic?
I assume that one's directed at me. That's a good question, and as I saw that pop up, I cannot answer that now. We've been focusing so much on the nutrients. We can certainly query that, right, and look for what the phosphorus concentrations are like, because it's not been the focus. So apologies, can't really speak to that right now.
I can say that we don't have, so as I was saying in my talk, there are thresholds that are set for different parameters to protect the designated use is. And for sturgeon pool, a Class B ponded water, there are not thresholds for arsenic. And I know that's not satisfying, but we did sample it regardless. And I can tell you that concentrations were mostly below 2 micrograms per liter, and were highest down by the bottom sediments. We had 2 measurements right near the bottom that were above 5. But again, there's no threshold for regulation of the designated use based on those parameters, or that parameter.
Great, thank you. I know there's been questions about metals in the Wallkill, so that's great to know that that data is available, even if it's not. And thank you, Alena, for digging into what you have for sturgeon pool. What does a bloom of euglena tell us about water quality, even though it isn't a HAB? And I'm wondering, I think I might have taken that photo that you showed. It looks very close, similar to the 213 bridge over the Wallkill River, a site that I've seen several times. So what information, if any, does a bloom of that kind give us?
Yeah, I saw that question from Jen Epstein. Am I muted? No, okay. So that's a great question. So first of all, I got the photographs from Rebecca Gorney, who coordinates the Harmful Algal Bloom program, and it sounds like she got it from you, so that's pretty cool. But remember when I was talking about how we protect the recreation use of ponded waters, is that we did a statewide survey to try and determine at what point are the nutrient concentrations so high that it's causing enough algae blooms that people are deterred from recreating. So this is a roundabout way of answering the question, but what I'm trying to say is that even if it's not a harmful algal bloom, algae blooms like euglena are not pleasant to swim in. And so therefore it's considered it prevents us from wanting to recreate in the water. So it's something that we need to protect for, to preserve the recreational use.
But it doesn't necessarily tell us anything about the phosphorus levels, or like it would be an indicator of some other kind of water quality impairment.
Well, I mean, algae blooms are triggered by higher nutrient levels. So yes, the only reason why we put so much attention on the harmful algal blooms is because those cyanobacteria species have low levels of toxin that can give people rashes or can affect dogs when they lick their fur. But all algae blooms indicate, algae blooms like I showed pictures of indicate a problem with nutrients.
Great, thanks for explaining that. Were bacteria measured during any of these assessments?
No.
No.
And this question is in reference more statewide than Wallkill specific, but is there any update on the 2018 303D list being published?
It was published. So it's available on our website. I can pop the link in the chat. So the 2018 list was finalized, and I believe that they're compiling the 2020 list currently.
Great, it's great news. And then for the new assessments for the Wallkill, when would those be expected to be out?
So the official 303D assessments and water body inventory assessments, as Lauren said, those are being worked on right now. And so our 2020 data would be incorporated in those as well.
Great. The only other question we have is just a comment, which is Ulster County thanking Rob and the Wallkill River Watershed Alliance for the MS4 reporting assistance they've given to the municipality, which is a designated MS4. So mark check for that one. And I see that Lauren's put that document into the chat. So you'll be able to see that 2018 list that's been approved by EPA. So there are no further questions. I'm going to hand it back over to Kyle, I think, to close the summit.
Yeah, just wanted to say thank you again to all of our speakers. That was very informative, and we're looking forward to how this science informs future decisions. And thank you to everyone who attended tonight. Thanks all.